Okay, I'm Sean Williams, and I'm going to describe this information retrieval system that I developed with Java 8 within IntelliJ IDEA and using Gradle as the build system. So the first thing is you must have MongoDB installed and running on the application. So once it's running, here you can see it's listening on port 2701. You can start the application either with Gradle or via IntelliJ IDEA. So here I just click the green the green arrow button here to start the application. The first thing that it does is it checks to see if there are existing tables, and if those tables exist, then it will attempt to build the index from those tables. If in this case I already started this, but there is no data within the collections that this application uses. So here you can see that there are 4 commands that you can execute against this, and at this point it only supports 2 domains, so CNN.com and Fox News is the other one. So the whole entire point of building this application was that I wanted to be able to query an index or a system and then return both a conservative article along with a liberal article, so that you can kind of compare and contrast between the two. And so this is kind of the rudimentary workings of that idea. So the first thing we have to do is fetch, because there is no data, there are no articles, there's no index at this point. You can see that there are 0 items in the queue. It asks if you want to delete the queue. Well, there's nothing there, so we can just hit enter. In this case, I'm going to fetch from CNN.com first, and it's really important that you type this in correctly. If you don't type it in correctly, you might get a null pointer exception or something else. The application will fail and it will just crash. So here I'm going to fetch from CNN.com, and I'm going to put 200. It's relatively quick. So 200 is, and this is a liberal section. It's a liberal article, and so the 200 is the fetch limit. It's basically the number of pages visited, not the number of articles that it evaluates and saves to the database. So in order to get a sufficient set of articles, you have to make this sufficiently large, maybe 3,000. If you put it up to 3,000, you might end up with 1,000 articles in the database. I've done it, and it's relatively quick. The next thing, you put in whether or not it's liberal or conservative. So CNN is more liberal and Fox News is more conservative. In order to fetch the text correctly, you have to specify which HTML class element is used, or what contains that data. In this case, I already looked, and it's ZN body paragraph for CNN, and for Fox News it's article text. So once you do that, you'll see that it starts fetching. Well, in this case, these links that are being displayed are not actually fetched yet. These are the ones that are just being put into the queue. We won't know what's being fetched until we actually query the database. So here I already have a connection to the database, so I'm just going to say use Truthly is the name of it, and then I'll put that down. And then if I type db.articles.count, you can see that there are 70 so far. So if I keep doing this, you see that it's fetching, and it's going. Maybe it's stopped now. Actually, not yet. So it's going up. But if I change this to db.visited.count, you can see that this number is going up. Right, so it's visiting these sites. So we will wait for this to finish, and here you can see that it did finish. Now the important thing to note is that there's nothing saved in the database with respect to the index. That is purely in memory. So in order to save the index, you need to issue the save command, and once you do that, it will save all the data that's stored in memory to the index. And what is the index? So the index consists of this term to documents, right? So you can see there it's already saved, right? It's term to documents, and then there's the document to terms index, and there is 100. Now the idea is that the number of articles and the number of document to terms should match, right? Because if you fetch an article, then that article also needs to exist in the document to terms index as well. So here they match. I've noticed cases where they got out of sync, and I'm not quite sure how. So now that I've fetched these articles, I can query against it, but there won't be any conservative articles that get returned. So for example, if we just pick, this is actually a good term, or a good query term, I think. If we just enter the query command and then search North Carolina governor concedes race, we'll say and we set the limit to, let's set it to 3. Notice conservative is blank, but because we don't have any data for that, but then 3 articles were fetched, and I'll scroll back up to the top so we can take a look at that. You can see, here's the final score, right? This is the normalized score, and then this is the initial score. So all the terms and the weights get accumulated using TF-IDF and the weights of the query, and this is the normalized score to help reduce the score or make it so that longer articles aren't favored as a result of more of the keywords being stored. So it doesn't, in this case, right, it didn't return very good results. We saw the link that we wanted to return, and it did not return that. This is a fairly long article. And then here, Poland hearing. So not doesn't look like it's very effective, at least when there are a few number of articles in the database. It's really important, I think, to have a sufficiently large data store before you can really see some effective results. So let's continue and get the conservative set. So now I'm going to do another fetch, and then I'm going to say yes, I want to delete the index because I don't want to continue searching for the liberal articles. I want to start with the conservative articles. So this will clear that index, and now I enter the new domain, and I'm going to set the limit to 200 again, and I'm going to change this now to conservative, and then we select article text. And it's really important to type all that stuff in correctly. I do not know what will happen if you enter invalid data. The other thing that I noticed in this application was that these hashtags, there are some links in CNN and some other articles on that site that have hashtag and then a local reference, and this application doesn't account for that. And so in those instances, I saw the same article with a different hashtag being returned within the top 10 results because it assumed that it was a different page when in fact it was not. So while this is searching, it shouldn't take that long. I can explain the resources that are listed in this application. So here's the resources section. I used the time test data set to get a preliminary results regarding the effectiveness of the documents that are retrieved. As you can see from the results that we saw here, it didn't do so well. It did return one of the documents for the first query, but for the other 2 queries that I used to test it, it did not return any of the relevant articles from this test set. Then we have the DB configuration file, which is here, which is already displayed. It just talks about what the names of the tables are and then where the actual database is located and the DB name. And then I also have this stopwords.txt file that shows you or tells the application which words need to be removed during the parsing step. So this completed. Now we know that we have the complete. Oh, so one other thing to call out: it runs the IDF, or calculates the IDF for each term, and then it also computes the document length for each term, or for each document, and then it completes, updates the index. So now we can query this and say we issue a query command and then enter travel ban immigration policy, and we set the search results to 2. Here now you can see Fox News was returned, right? And there should be 2, Fox News 2, and that looks fairly good. We can see there's the immigration in the title, at least. The travel ban is listed there, and then here's the liberal side, travel ban. And we go up here, there's another Trump travel ban. So this result actually worked out pretty well versus the other one not so well. Again, it's really important to have a sufficiently large index, and this just happened to work out because that's probably more prominent, or it was able to fetch those first because it's more recent. So let's really quickly save this index. The last thing is just exiting. When you exit the application, it also saves the index. So I will exit, and it's going to save the index. So I'll quickly explain, just a real quick overview. I think that this application can be refactored. I think there's a lot of additional efficiencies that I can build into this. There's code patchwork that kind of went on as I was troubleshooting and debugging different things. So the first thing is this DB package. The DB package contains all the classes that pertaining to writing to the database. Data source 2 is the one that's being used. If you see 2 classes and one has a 2, it's the one that has the 2. I haven't refactored it to remove the old classes just yet. The index class contains everything pertaining to indexing. So for example, the most important one is this indexer 2. The indexer 2 actually contains the dictionary, and it contains 2 dictionaries, one for the term to doc dictionary, and then one for the doc to term dictionary. And then the dictionary actually, the dictionary, second, let me drag, and then the dictionary contains a map of the actual term or the document. And this is type. This is another thing that I think needs to be refactored. Dictionary should be an abstract class, and get rid of this type information and just inherit from the dictionary class. And then within the dictionary you have either a token info, which houses, the token info class either houses the token info class actually houses the term with the IDF, and then it has a map of occurrences, document occurrences. And then for the document info, or the doc to term dictionary, you have the document info class, which is very similar, except it's on the document side. It has a doc ID and a term occurrences, and that just makes it easier to calculate the IDF and the document score, and to look up and so forth and so on. And then we have this parse class. Parse class is just the parser, which actually removes various tokens from the source text. The retrieval class is responsible for querying and storing the scored document. The max PQ is how I rank the docs, so I'm able to just put these items into a max PQ and fetch them out one by one, getting the highest ranking item. The stemmer class is just the Porter stemmer algorithm. I just copied and pasted that. The same thing with max PQ. I just copied it and pasted it from